Welcome to this YSL Microsoft Excel tutorial. In this video, we're going to look at how to use the sequence function to calculate sequences of numbers. We'll begin with some basic examples to calculate simple row and column sequences and show you how you can change both the start and the step values of those sequences. We'll look at how to use the function to calculate sequences of dates, and towards the end of the video, look at how to use existing values in the worksheet to create your sequences. So let's get started. For this example, I'll be using a workbook containing a list of the top 50 highest grossing movies. If you'd like a copy of the same data to work on so that you can follow along with the video, you can download a copy of this file using the link in the video description. As it turns out, to demonstrate the basics of the sequence function, I'm going to start in a blank worksheet in the same workbook. So the sequence function is designed to calculate a sequence of numbers, and the simplest possible sequence you can create from this function starts at 1 and increments by 1 for each row. So if I start in cell A1 here and enter the sequence function, the only compulsory parameter I have to fill in is one called rows, and I'm going to fill that in with the number 10. So what that's going to do is generate a sequence of 10 numbers starting at 1, listed vertically, and ending in cell A10. So the sequence function is another example of a function which returns a dynamic spilled array. And if you're not sure how spilled arrays work, then we do have a video which explains how they do work. So if you need a bit of a primer on spilled arrays, that's a good place to start. But there you go, the simplest possible sequence to create. If you'd prefer your sequence to run horizontally rather than vertically, then let's just modify the formula we've entered into cell A1 there. I'm going to change the value of the first parameter, rows 1, and then set the columns to 10 instead. So set the value of the second parameter to 10. So if I enter that one now, we'll end up with 1 row and 10 columns, but again, counting from 1 through to 10. You can also create a sequence which spills across multiple rows and multiple columns at the same time. So to do that, let's modify the formula in cell A1. I'm going to count over 5 rows and 3 columns. So by default, the counting works horizontally first, so 1, 2, 3 across the top row, all the way down to 15 in the bottom right-hand corner. If you'd rather have your counting work vertically first, then horizontally, then you could transpose the results. So we have a separate video on the transpose function if you want a bit more detail of how this works, but if I just wrap the transpose function around the sequence function, that's going to convert the rows into columns and columns into rows. So this time I'm going to get 3 rows and 5 columns, but it'll count vertically downwards first and then horizontally. If I wanted to count vertically with 5 rows and 3 columns, then I just have to make sure that I flip the numbers around in the sequence function before I transpose it. So sequence 3, 5 transposed goes 1, 2, 3, 4, 5 in the first column down to 15 in the bottom right-hand corner. If you don't want your sequence to start at 1 and increase by 1 for each new item, you can change both the start and the step parameters to influence that. Let's replace the sequence in cell A1. I'm going to select cell A1 and then hit the delete key to wipe that out and the entire spilled array, and then we'll begin a new sequence. This time I'm going to fill in 10 rows and 1 column, but I'm going to start at the number 5 this time. If I then close the round brackets and hit enter, you'll see the counting simply begins from 5 and goes up by 1 for each new item. I can also modify the step value then. Let's head back to cell A1 and edit the formula this time. And if I click back inside the round brackets and type in an extra comma to get onto the step parameter, I can increase, let's say, by 10 for each new item. So if I hit enter now, we'll see it starts at 5 and increments by 10 for each new item. You aren't limited to using only whole numbers when you set up these sequences. You can also use negative numbers to, for example, count backwards. So let's edit the formula in cell A1 again. We'll begin with 10 rows and 1 column starting at the number 5, but this time we'll step by -1. So entering the formula, fairly simply, just decreases the count by 1 for each new item. You're not limited to using only whole numbers when you set up your sequences either. Let's modify the formula in cell A1 again. I'm going to this time start with 10 rows and 1 column, but I'm going to begin the sequence from 0.1. And then the step value is going to be 0.02. So if I enter that formula there, we get this list which increments by 0.02 each time. And then perhaps if we applied a percentage format to that, it might look a little more readable. There we go. So starting at 10% and incrementing by 2% for each new row. The sequence function also works really well with date values. After all, to Excel, a date is just a number with a fancy format applied to it. So let's set up a new sequence, this time starting in cell C1. I'm going to type in equals sequence, and then I'll fill in just 5 rows this time and 1 column. And I'm going to start using today's date. So I'm going to enter the function today, which is a slightly unusual function in that it has no parameters, but you still must open and close the round brackets there. I won't fill in the step value just for now, so by default the sequence will increment by 1 if I enter that formula. So it starts with what doesn't look very much like a date, I agree, the number 44,688. But were I to format that list of values as a date, then you'll see that it has indeed started at today's date, or at least the number representing today's date, incrementing by 1 for each new item. So each individual day, each 24-hour period, effectively has a value of 1 to Excel. So if we counted up by 7, then that would create a sequence of weekly values. So let's modify the step value in cell C1 so that we step by 7, and then we'll see we get the sequence of weeks. You could also combine the sequence function with other date functions to create even more interesting sequences. So let's say, for example, we were building a cash flow where we wanted the start date for each month listed as a column heading across the top row. If I wanted to construct a date that started on, let's say, the 1st of April of the current year, I could formulate a date using the date function. And for the year, I want to calculate the year of today's date. So I'm going to use the year function and then insert into that the today function. So that in this case generates the number 2022. Then for the month, I want the month to be April, so I'll enter the number 4. And for the day, I want the day to be the number 1. If I then close the round brackets and hit enter, it'll calculate that one single date, the 1st of April 2022. If I wanted that sequence to calculate the first day of each of the next 12 months, then I could insert the sequence function inside the date function. So where the month parameter is for the date function, I can remove the number 4 there and replace that with the sequence function. So I want to generate 1 row and I want to generate 12 columns. I want to start at the number 4. I'll get that right eventually. Start at the number 4 and the increment will just be 1, so I can omit that. But I'll just enter the step value as 1 there just to be explicit. If I then close the round brackets at that point, that will generate a spilled array of 12 cells. It hasn't applied the correct format to everything there, so let's just select that array and apply the date format or the short date format. So you can see we're getting the first date in each month, starting in April 2022 and ending in March 2023. For the final few examples, I want a sequence to be based on values already stored in a worksheet. So to demonstrate this, let's head over to the top 50 movies worksheet, and we're going to be looking at the runtime minutes column there. Just to help with the next few examples, I want a convenient way to reference the values in column D. So I'm going to create a named range using the label in cell D2. So I'm going to select cell D2, hold down Ctrl and Shift and tap the down arrow key to extend my selection down to the bottom of the list. And then from the Formulas tab in the ribbon, I'm going to choose the Create From Selection option. I'll use the label in the top row to create a new range name called Runtime, which will reference everything from cell D2 down to, cell D3 down to the bottom of that list. So there's my range name. Now what I'd like to be able to do is create a sequence that begins with the smallest number in the runtime column, runs to the biggest number in the runtime column, and fills in every value, every integer between the top and the bottom end. So to do that, I'm going to need to know the minimum and the maximum of the runtime column, and then I'm also going to need to know the range. Let's create a couple of formulae to get that for us. So I'm going to head over to column J over here, and in cell J3, I'm going to type in the word min, and then in cell K3, I'm going to say equals min, and then refer to my runtime named range. So that gives me the smallest number in the column. Then below that, I'm going to type in max, and here I'm going to say equals max, and then again fill in a reference to my runtime named range. That's the biggest number. And then I can work out the range by subtracting one from the other. And because I want the range to be inclusive, I'm just going to add 1. So I'm going to say equals, and then simply take the maximum minus the minimum and add 1 to the result. Now the point of doing that is that I can now create a very simple sequence that starts at that number and has that number of values in it. So effectively I'm counting from 88 to 201, but filling in every intermediate value. The point of doing this is so that I do get every intermediate value between the top and the bottom. There are lots of numbers in this column, or 50 numbers in this column, but there's a range of 114, so there must be gaps in the sequence. So if I head over here to column M, and in cell M3, I'm going to say equals sequence, or attempt to do that at least, try again, and again I'll get there eventually. And the number of rows I want to generate is the same as the range that I've just calculated. The number of columns is going to be 1, and I'm going to simply start at the minimum value of that range runtime. I could also explicitly state my step value, which is going to be 1, although that would happen automatically, but let's leave it in there, close around brackets, and there's my sequence starting at 88, ending at 201, with every possible intermediate value filled in between. I could then use the results of that sequence to count how many films there are with that runtime. So let's just quickly say in column N equals countif. The range I'm going to count the values in is the runtime range, so I'll use my named range for that. And then the criteria will be applied by the sequence I've just calculated. So I'll refer to cell M3, followed by a hash to reference the entire spilled array, close the round brackets, and there's my count of all the films with each value of runtime between the minimum and the maximum. Taking things a little further, let's say we wanted to take that continuous range of runtime values and divide them up into different bands. So to do that, we could add a new label to cell J6. Let's call this one bands. And let's say we wanted 5 different groups in this list. Then we can use that to calculate the interval or the step value we're going to use. So here we can just simply take the range in cell K5 and divide that by the number of bands we've entered in cell K6. If we wanted that to be a whole number, an integer, we could use the round up or round down functions wrapped around that expression. So let's here use the round up function, and I'm going to say round up K5 over K6 to 0 decimal places. So there we go, a nice whole number. Now that we've got that, we can calculate the sequence for our bands. So I'm going to head to cell J9 and say equals sequence, and the number of rows I want to get is equal to the number of bands I've requested, so 5 in this case. Just the one column as usual, and then the start value is going to be the minimum number in the runtime minutes column. I can then set the step value to be equal to the interval that we've just calculated, and then closing the round brackets and hitting enter gives us the thresholds for our different bands. Now to work out how many films there are in each band, the criteria are a little more complex than our nice simple countif function over here. We've got to match 2 criteria for each band. So the value of the film's runtime must be both greater than or equal to the minimum number for the band and less than the minimum number plus the interval. So to construct that as a formula, let's say equals countifs, and the criteria range 1 is going to be the runtime field. Criteria 1 is going to have to be concatenated out of several parts. So in some double quotes, I need to say, first of all, greater than or equal to, and then I'm going to concatenate that with the value of J9, and we might as well use our dynamic array, so I'm going to use the hash symbol to reference the entire dynamic array. So that deals with criteria number 1. I'm then going to enter another comma and refer to the runtime column again. And then criteria number 2 is once again going to be concatenated. It's going to be less than, in some double quotes, concatenated with the value of J9. And again, referring to that as a dynamic array with a hash symbol, plus the interval that we entered or calculated in cell K7. So putting all that together, if we then close the round brackets and hit enter, we'll get the count of films belonging to each of those bands. Now the point of doing all that is so that we could create some simple charts representing the frequency for each band of runtimes or even each individual runtime. So if I just select the column of count that we've just calculated for our bands first of all, and then head up to the Insert tab in the ribbon, find the basic column charts and insert a 2D column chart, I could then change the labels on the columns there so that they reference the starting point for each band. So if I head up to the Select Data button there, edit the horizontal axis labels, and then reference that column of values there. Hit OK, and then OK again, and then we've got a nice little sort of frequency distribution of runtimes in different bands in our list. So there you go, there's a few ideas for generating sequences of numbers using the sequence function. Hope you found some of that useful. Thanks very much for watching, and we'll see you next time.